Test, test. Perfect. Test, test, test. So, y'all fuckers said that you wanted to see my reaction to part 2. I just finished part 1 with, by the way, just look at that. Look at that gorgeous iteration. Mwah! I could probably automate the growth, but I did it manually for this. But like, look at that. Look at that love. You can just see it spread and grow and mwah, beautiful. It took a while for me to be able to get it to work. I removed a lot of the cornery kind of fucky things. I made it just so that it refers in like blocks. You see like the big blue, dark blue borders around things? That's an extra bit of like buffer blocks intentionally so I can target those areas and not have to worry about overflowing into other areas. This makes things a lot easier. I'm going to read part 2 now, because apparently it'll be hilarious. I don't know whether it's relative to my previous solution or whether it's hilarious relative to just doing it in Excel in general and this method of like blocking and swapping. So continue to so you can see this page only exists when haven't seen it yet, and this is still So continue to part 2. For some reason, your simulated results don't quite match what the experimental energy source engineers expected. Apparently, the pocket dimension has, for fuck's sake. Oh, it is 4 dimensions. No, it is a 4th dimension. At every integer 4-dimensional coordinate, there's a single cube, which is either inactive or inactive. Oh, no. Each cube only ever considers as neighbors. Any one of the 80 other cubes or of any other coordinates differ by at most 1. Balls. God damn it. The initial state of the pocket dimension still consists of a small flat region of cubes. Furthermore, the same rules for cycling updates still apply. During each cycle, consider the number of active neighbors of each cube. They'll consider the same initial state as the example above. Even though the pocket dimension is 4-dimensional, this initial state represents a small 2-dimensional slice of it. Particularly, this initial state defines 3 by 3 by 1 region of a 4-dimensional space. Simulating a few cycles from this initial state produces the following configurations, where the result of each cycle is shown layer by layer, given... Oh, God. The full 6-cycle boot process complete. Okay, so still only 6. How many cubes are left in the active state of the 6th cycle with the 4-dimensional space? Okay. Fuck. Okay. I think... Buffer size spread grow. Okay. So this question is doable in Excel. It's not nice, but it's doable. Because it's only 6, I can hard code the sizes. That's not an issue. So, here's how these were done. Oh, for fuck's sake, how do I don't have the friggin... I can't see it on my screen right now because the camera's in the way. Okay, so you see here how this is of size... It's in a space of size 8, but I made this just say 10, just for convenience, and I'm able to say 10 all the way up here. That's fine. What my 3 dimensions is dimension 1, dimension 2, and then dimension... Well, I mean, I could probably scroll. I'll just show this a little bit better. So, this is everything that shares the row with it. This is everything that shares a column with it. This is everything that shares a depth with it. All of those. So, my question... Since I always know that they'll always only buckle out 1, and this maximum size will be what? If it's going to go 6 iterations, it won't go any further than this. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20. So the original one is 8 by 8. Every iteration increases it by 1, so it goes up to 20 will be the maximum after 6. Because after 1 it'll be 10. Increasing by 2, so it'll be 20. Okay. So if I start with a 20 by 20 for all of these, which will be how I'm going to end up doing this, I have to do a 20 by 20, and I know that there's 4 dimensions that I've got to work in. So it'll be 20 by 20. I have initial... Actually, wait a second. That's not true. Okay. I'm going to open up a new sheet to explain this. So, The one that I had before was a 3x1x1, sorry, a 3x3x1 space. That's what I had originally. And then, when I increase every one of them by a matter of 6, I then have in every direction, because I had 1, but it was doubled in both ways. So I'm really increasing each one by 12. Sorry, it's not 3x3x1. It's sorry, it was 8x8x1. That was the dimension I started off with. So I'm increasing each of them by 12 in every direction. Bam, bam. So I can simulate this one because it's identical in the Z dimension. It'll also be identical in the W dimension because you're expanding in the opposite direction as well. So 8x8x1 would become 10x10 by 3, and that'll become 12x12 by 5, etc., etc., etc. But I was able to realize that, hey, the top and bottom of this dimension, because we started off with 1, and it was symmetrical, will stay symmetrical as it grows. Which means, in reality, all we're really working with here is 10x10 by 2, and I can do a little bit of math fuckery afterwards. That becomes 12x12 by 3, that becomes 14x14 by 4, etc., etc., until we all end up at whatever this will be. May as well finish it off. 18x18 by 6, and then 20x20 by 7. Now here's the thing. All we're doing is we're taking this, and we're turning it into... Actually, let's do this. Oops. I fucked that up, right? What's that a value? Oh, because I'm... There we go. Wait, not by 3. But... There we go. So what 8x8x1 becomes, it becomes 8x8 by 1x1, and by the exact same degree that we showed before when we were talking about it's being like it being another like flat dimension we don't really care about because it's just going to be symmetrical. Really, this is what we're going to have in the end. We're going to have a 20x20 by 7x7 area. So if I can get a 20x20, and I can then have a symmetrical depth and width relative, I can essentially have a... If we just say, for example, let's for the sake of argument just say that this is a 20x20 space. There we go. That space right there is 20x20. You can obviously tell that's 20x20. What I'm going to do then... Actually, yeah, we could do it like this, just to show. There we go. That's 20x20. Do you see that's 20... 20. And then what we can do is we can do modulus and increase, and say, well, the W and Z will interact with each other, but not very much, and not in a way that's meaningful. So what I can do is I can say, well, if it only matters based on one direction, like anything that matters one way from itself, we can then take this and say, well, then all of these are all the next dimension. So inside a little tiny square right here is a 20x20 square, and then we have another 20x20, another 20x20, and that's, before what I was doing was this as my one dimension, and saying that these were stacked on top of each other. Now I'm going to have them stacked next to each other as well. So anything that has an x coordinate of here, actually what would it be is it would be, you'd have an x and y relative in here, so 0 to 20, so this little bit would be 0, that would be 20 up here, 0 to 20, and then we would then say, okay, so now, coming up this way, our now z dimension is going to increase by 1, by 1, by 1, by 1, by 1, and here we say our w dimension increases by 1. So anything that's within range will be anything that's within a little 3x3 of any of the adjacent ranges. So, if, for example, if I pick this exact cell, that one right there, and there's like a little 3x3 square in here that we say, okay, like there's one tile. We care about this tile. Is it going to be adjacent? What I'll then say is, well, let's look at the 3x3 in my current dimension, because that 3x3 is the x and y of that. And then I'll then say, look at that 3x3 in the next dimension, which would be in this one right here. Say, well, in this square right here, does it work? And then I'll also say, does it look in this one? That's what I did before with just 2 dimensions. Or sorry, with just 3 dimensions. Now adding the 4th dimension would just be doing that. So all I'm doing is adding an extra check. Actually, that's not true. I wouldn't just be doing that. I have to do these as well. Because these also all differ by an x and z of 1. It's just that they do both x and z by 1. So now I have to do an extra meta layer on top of it. So that's going to be tons of fun. I think... because this is only going to be, it's going to be a 200 by 200 space. And I'm going to have to then copy them over and then do the math over again multiple times over in order to get this to work. But I think it's doable. So I'm going to start fresh because the math that I did is not like what I did before to understand the question is what I'm having here. Okay, so let's start off by, let's make these 25 and make these 25 just so I have a... So you can very easily tell that that's 20. I'm going to scroll down. I'm going to make this 20 as well right there. Okay. So we are going to call that a gray. And then what I'm going to do is I'm going to then do another 20 by 20. Scroll all the way down to here. And I'm going to make that sort of a light gray. We're going to make that a darker gray. And now that's where we have the fun. Because that's 2, 4, 6. Oops. Oh, I guess it went up to 1,000. Why the hell? What the heck is happening? Sorry about that. So that's 6, 7, 8. I'm going to go up to 400. So we'll be here for a while. Actually, I could just do this. There we go. And now we've completely tiled that area. And if I zoom out, you can see it a lot better. That this area is now tiled. That is 1 space. This is 1 of our 20 by 20. So right now, this would be representative of a 20 by 20 by 1. Sorry, 20 by 20 by 20 space. We need to go 20 by 20 by 20 by 20 in order for this to work. So I'm going to come here, paste in here. No, I'm not. I'm going to paste in here. And then I will copy that, and we will dye it the dark color. Is dark last? Yep. Okay. We'll copy that. Actually, you know what I can just do? This will probably take a lot less time if I just do this. I can see that it says 120 on the right there, on the left there. I'll just grab this and drag down. Bring it to exactly 400. There we go, and that should just tile the pattern properly? Yeah, it will. Excuse me, hello? Oh, did I... Okay, so there we go. This... I can't zoom out any further than that, which is hilarious, by the way. Which means we're going to have to do this slightly differently. I'm going to have to do select all. We're going to bring that from 25 down to 12. And let's bring that down to 12 too. So that right there is 1 of our 20 by 20 by 20 regions. So this right here is going to account for... So essentially, so what the original question was, it was a 4-dimensional problem. The very, very first one, part 1, it had an x-coordinate, a y-coordinate, a z-coordinate, and a time coordinate, where we cared about the iterations we were doing on. Now we're doing a 5-dimensional problem. We're going to have this, and then we're going to have to do the next step downward. Beneath this is going to say, well, let's do the math, and we're going to look at the previous 400 by 400, the top 16,000 values, and then use that to compute what the next iteration would look like. However, it should be pretty easy to put these values in, I think. So the thing is, it doesn't even need that by 20, right? It only needs to be 20 by 20 by what? What was the other thing? 20 by 20 by 7, right? 20 by 20 by 7. So I could even remove a bunch of these and just make it a 20 by 20 by 7 by 7. That's all I really need, and then I can iterate, right? So, gee, what? I didn't even need all of these. What am I doing? Yeah, so right now this is... Okay, I'm going to change something right here. I'm going to... Because I've now decided how I'm going to be doing this. I'm doing desktop too. It's going to occur for a couple seconds. Sorry, one more time. There we go. Okay. So, as we showed before, it's gonna this final question is going to be a 20 by 20 by 7 by 7. So, that's so 7 by 7 means that we're going to go to 140, which is right here. Those are the only ones that we need, so I'll just delete the rest. Well, I'll delete the rest. There we go. This should be sufficient, right? By 140. Okay, so now I can actually go back in and slightly change this a little bit, because now we have all the values that we're going to need for all of our iterations. Here, actually no, it's not. So yes, it is 7 by 7. But we're going to start here. So we're going to start here, and I believe, if I'm not mistaken, that this is still going to be symmetrical. I think this still stays symmetrical. Yes, because anything that's going to be here will be influenced by this and that. Wait, it'll be influenced by the one above. So it's going to be symmetrical, but I'm going to have to do the 2 for all of these edge sides and all of these edge sides too, where it counts anything that comes from down here as double. This counts as anything down through there as double because all of those are counted in both dimensions. Here, I just count this, and those guys. But this, I have to count all of those as double in order to account for the other 8 that it looks in the opposite direction. Okay, so we have a starting input. We can toss it right in here, but we're going to try tossing it so it's directly centered. So here is our little middle area. Let's go grab my input. I'm going to manually put in my input right now because I do not care. By manually, I mean like I'm going to like do it automatically, but I'm going to like do it like this. So it's going to be row, column 6, start num. So 7 to 13. That's that row all the way down here. That's correct, right? Oh, do I do one? It should be 7 to 14. Yeah, just double check. One higher will be blank. One higher will be blank. Perfect. Take those, bring that down. Oh, sorry, I meant to do this. Paste values, and now that I can remove that. I've now successfully put in my default input, and now I can start iterating one by one. But whoops. Okay, you know what? Let's just do this. This is gonna be faster. Just womp, womp. There we go. This is going to be my starting input. And now every other time it's going to iterate one extra dimension out in every single way. So this is my pure fresh starting location. Everything else will be considered dots. So I could just fill in the rest of everything with dots. I'm not going to bother because right now the way that... Oh, this is right? 7 to 14. Space on top 6. Perfect. Okay. I'm not going to bother because the way that I've been doing this problem has been by which looks a lot nicer, I guess, but it's been by checking if there's a hash in it and then ignoring anything else. So the dots actually don't make a difference, but I have the dot there just so I can visually see that something's being processed. So now that I have all of this, and I have to recopy this entire area here, and now I have to manually check for each of the dimensions. How am I gonna do that? Fucking, I don't know. It's gonna be like semi-manual, essentially. Oh, actually, there is one thing I want to do, because this will make things a hell of a lot easier. I'm going to grab this. I'm going to drag this down. Because, so why am I doing this? I want to get myself a buffer in every direction, so that when I'm looking at like one tile in a 3x3 and how it grows, it is going to grow in all of these directions. So I need to get an extra 2x2 buffer in every direction, which means, oh man, automaton is going to be difficult, ain't it? No, I could probably just ignore it if it's greater than... No, the 3 will be a pain in the butt. Goes up to 20. Okay, you know what? I want to redo this. I want to redo this. Instead of 20, I'm going to use 24. Just because 24 means I'll have an extra 2 buffer, so that when I'm doing any of these... I'm just going to copy that. Let's paste it here for now. I'm just going to delete that, and we're going to try this again one more time. We're going to do 1 to 24. 24. We're just going to do blue and red for now. Just so, I'll change them to a different color afterwards, but right now I'm just going to do blue and red. Blue, red. Okay. Paste values. Oh, sorry, that's no longer on 7. I was on 7, but then we increased it by 4, so now we should be on 9, because now our middle's on 12. So here I should be pasting by values. There we go. That is all we're going to have as our final input here. So now I can copy this, and I can copy formatting, and I can copy this. There we go, and I can just paste upon the rest of everything else here. So, 1, 2, 3, 4, 5, 6, 7, 8. I need it to be, because I'm going in each direction, I need an extra buffer of 2. Realistically, I don't need it on the lower, but I am going to do the lower anyway, just because it's going to give me peace of mind. Actually, I could do this as well, because I know that some of these are never going to be used. Most of this is never going to be used. I'm going to do this. I'm going to show the areas that aren't going to be used by using a dull yellow color, showing that that is part of the buffer that I don't care about and will not be relevant to this question ever. Okay. And now that I've done it with yellow, I'll come over here and I'll do it with a slightly different shade of yellow. Just so I can still differentiate the borders fairly easily. Because it's going to be relevant, being able to differentiate the borders. Use on nothing. Okay, so that looks fine to me. I will then copy that. I'll come here, then paste the formatting only. I'll then copy that, and then I will paste the formatting only. Okay, so now we've got the buffer done. Formatting only. Formatting only. Oh, and you might wonder why I'm allowing this to be in the corner up here, because these are the 2 dimensions that are symmetrical. This is not a symmetrical input, so I cannot symmetrically represent that. If I could symmetrically represent it, I would remove one of the dimensions as well on the other one and just do it mathematically. So that's how much? 6, 8. So I only need 7. I can do 1 more here. Formatting. And because I only need 7, I can remove the rest of these here. Bye-bye. I can delete... There we go. That's what I was looking for. Whew. Deleting is so tricky. Oh my gosh. Okay, then I will paste formatting only. That's 4, 6, 8, 9. It's 10, but I only need 9. There we go, which means whenever I'm referencing any of these values, there should be absolutely no issues whatsoever with directing it. So, this is our very first input. This gives us absolutely nothing. There is not, like, this is our iteration 0. So, what I'm going to do now is I'm going to copy this entire area. Why am I going to copy the entire area? Because then it gives me a bit of a framework to use. I'm going to be creating a function that I can ideally just spread all the way across to be able to identify values. Oh, Jesus Christ. Gotta love Excel. There we go. All I'm going to do is just paste formatting. And now, actually, I'm going to change these a little bit. Actually, do I even want to do formatting here? I mean, I can clearly see this is different. But let's do it like this. Let's change up this size just a little bit. Because most of these aren't ever going to see a use. But I'm doing this just because symmetry is going to be very easy to use then. So that's light gray, slightly darker gray. That'd be hilarious if they were like literally the exact same color of gray and I just can't tell. Okay, they are different. But I actually had to check because I was not 100% sure. So why am I doing this formatting? It's probably not necessary. You're right, it's probably not necessary. If you're telling that to yourself, why are you telling that to yourself, Forrest? Stop it. Stop telling yourself that. This is absolutely necessary in order to get the engine of the mind going. Very important. Actually, the reason I'm doing this is because it makes all of my mental calculations and references easier. I want to have to change these colors. These colors fucking suck, dude. I don't mind the dark one, but the light one needs like a complete revamp. Be something else entirely. Let's do that. That's better. That just feels more distinct, and I can use that as a clearer distinction. Dark is blue, light is red. Okay. I'll go all the way down here. That looks like it's just grayscaled. Look at that lovely grayscale. So, we are starting in the top left corner here. Our main reference now is to say, how do we check all the values we need to care about? So, first of all, let's bring up a notepad and say we are going to check if our cell we want is RC, then what I want to do is I want to check row -1, column -1 to row 1, column 1. Those are the 9 within the actual cell. And now is where things get a little bit screwy. We're going to also want to check -1 plus 24. So I'm just going to do plus 24 here. Yeah. Then we're going to do plus 24. Then we're going to do plus 24. Plus 24. So that's the opposite bottom right corner. Oh man, there's going to be so many of these. We're going to do a 9 by 9 area. Oh geez. Okay. So. Actually, is it worthwhile? Actually, I've got the extra buffer. Yeah, I have the buffer for a fucking reason. I don't know why I have these here. These should not be here. These should be here. Specifically because I'm never going to put any tests up in these areas here, but the tests that I might do are going to reference these cells because it'll be a lot easier to just say, well, look at the 8 cells around. That's why I gave myself that extra buffer. Okay. Gotta keep myself thinking. Gotta keep it thinking. So, this is irrelevant. None does matter. I'll just leave that just in case. Okay. So, for this cell, if RC is my cell, then we need to care about this range plus or minus a bunch of 20s. So we're going to say, we're going to do R plus or minus 20. We're going to do C plus or minus 20 both ways. So, yeah, for every, yeah, plus or minus 20 or 0. Actually, I'm going to do plus, minus, ampersand to show that there's 3 different options. There's plus 20, minus 20, and not do anything with a 20. So, I'm going to have to do that manually. Okay. So, I'm going to have to do 9 different countifs. So, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to start by doing from the middle. No. I'm going to do from top left. So, yeah. From a tic-tac-toe across top left. Da-da-da-da-da-da-da. So, like, you know, like that, then that, then that. Like, in that order. So, I want to start. I'm not even going to put the equal sign right there. I'm just going to do like this. So symmetrical. Equals countif. What's the range? Well, our first range is going to be essentially this, but then we're going to be minusing 20 both times. So, minus 20. I'm just going to do this so I can do the mental math a little bit easier. Actually, it might be worthwhile to do it like this. So, row is minus 20, and then I'm going to go across, so then I have column is just column. Oh, sorry, that was wrong here. This is... Okay, so this is top left. I want to do up left, I guess. I'm going to up left and down left, yeah. So up left, and then we're going to have up middle, which means our row is going to be the exact same row, but our column is going to be un-20ified. Okay, I think it's going to be minus, minus, and then it's going to be plus, plus, like equals, equals, equals. So I think it's going to be like this. Okay, I just had to math it out a little bit so it'd be easier for me to work on. So this, this, this. Then this will be plus. Bottoms are... this will be minus. That can be removed. Middles are removed. Bottoms are plussed. Tops are minused. There we go. That should be all the references we need. This is fairly two-dimensional here. You can see that that row is like skipping every 3 is when the things actually change. So it's minus 20 plus nothing plus 20. And that's just how that is all the way here, but it goes minus 20, nothing, plus 20. Minus 20, nothing, plus 20. So I just go through all the different versions fairly quickly. And now I do count the number of that's. And I'm going to add them together. So now, what I can do is I can now take this value and then find what the next iteration would be by then bringing that up by just checking relative to here. This should just be correct and just count the values. So if that's right, it actually might be easier because I'm doing this in a very modularized way now that I've gotten experience from the previous edition. So I think I can just paste this here. No, because I'm dumb. I have to actually count these fucking values. Okay. Let's not be stupid. I actually have to, like, evaluate. I can't just put the numbers in there, because that'd be really helpful, and Excel doesn't have helpful things. Okay, so negative 1 minus 20 is negative 21. So these are all going to be minus 21. So anything that's a minus 1 minus 20 will be minus 21. Oh, gosh. So that's just going to be a 21. That's just going to be a 21. It's going to be a minus 21. That's going to be 21. That's going to be a minus 21. Okay, the minus 21s are only going to come in this column here. The 21s are only going to come in this column here, like here. The bottom's there. Okay, so now we're going to have the 19s. 1 minus 20 is negative 19. So positive 1 minus 20 is negative 19. Should see that on every third now. Okay, and now I should have minus 1 plus 20 should just be positive 19, which I should now see in the rest of these here. The bottoms. Okay, I think that looks correct. So now I can... I probably should have kept that separate just in case, but I think that's right. I can come here and just paste. Okay, so that is... Oh, wait, it's not 20. It's fucking 24, right? I'm fucking dumb. Okay, well, I mean, I guess we just reference 4 on each of these again. Oh, I did 24, not 20. Ba-ba-da-ba-da-ba. I'm a fucking dipshit. I am. So, minus 21 becomes minus 25. Let's do this numerically. Minus 21 becomes minus 25. Now, minus 1 stays minus 1. 19 becomes 23. Okay. 21 was 20 plus 1, so it's now going to be 25. Okay, this was negative 20 plus 1, so it'll be negative 24 plus 1 will be minus 23. There's only real 2 ways that you can do these questions, that you can see like which way they go. Is either like, are they opposite of each other? If they're opposite of each other, then they're 23. If they're the same, then they're pushing farther away from 0, so they're going to be 25. So it's going to be the plus or minus you care about. So this should now be correct if I'm not big dumb. And I know that I'm going to have to do the whole whatever, you know, the whole backwards value, but I want to just see if this is right. Now, like here. Look at that. So you see how we've got those values all down below? We're checking the full 8 in the full direction. Now that that looks like it's correct, I am going to cancel it out again because we've got to do one more check now. Now that I've actually shown that this is actually right. Now, we know that our cell that we're actually caring about is 216 higher than all of that. So for row, we have to knock it up another 216. So subtract another 216 from it. So that's for all of those rows. So minus 25s become 241s. We don't change the columns because this is aligned vertically. Because this was 25, this is going to be 2 closer, so it's going to be 239. So I can just add a 9 to each of these. But just those. So now I've got minus 1 plus 216. Oh, sorry, no, that's not right. It'll be 1 plus 216 because I'm subtracting it. It's going to be minus 217. Okay, and now for 1, this actually is going to make a difference. That's going to be negative 215. Because I'm going 216 and I want to go back down again. So I'm subtracting 216 from each of these. So 23 minus 216 gives us 183. Before I was just doing it slightly backwards, but there should be minuses. There we go. And that looks like it should be entirely correct. So let's double check one last time again. Okay. So we come here, we paste there. We scroll all the way to the very, very top. We should see the corners. Oh, which one did I fuck up on? Bottom left, 7. 1, 2, 3, 4, 5, 6, 7. Whoops. That was a 191. Okay. Yeah, I just messed up that direction. But now, they all seem to be referencing the correct cells now. So those all should be absolutely correct. So I can now hit enter. And I'll now count how many cells, how many there are in that iteration. So I can come here, and go all the way here. And now it tells me the exact correct amount of cells that will be in that position on the next iteration. So I can now just take all of these, and I can paste formula. And now I can take these, paste formula, and you see these are all going to be affected too. They're all going to be affected similarly, although not identical. Oh, also, I made a mistake. I have to do one more thing. Minus count if row minus 216 column minus 216. Now, why does that make a difference? Because you do not count your own current cell as well, which will make a difference in all of these. All of them will make a significant difference in that regard. So now I can copy this, and now I can paste in formulas. Uh-oh. Oh, it's staggering. Formulas. It's thinking. Formulas. And now what I do is I copy this. Paste just formulas. Paste just formulas. And one more time I can do it right here. I'm gonna do it in words. Just formulas. So now that is 2 down. Remember, I'm giving myself that buffer so I don't ever need it. Formulas. Actually, let's do it from here now. Copy that. Paste just formulas. There you go. Why am I doing all these right now? Because now it means I don't have to do them again. So now all of these will contain exactly how many adjacent each of the other ones are. So I can look back on these on the next row and say, okay, now how does this expand? You'll also realize that from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 total is referencing, and it goes 1 in every direction. So these are the only ones that are actually going to be of use. And then we're going to keep iterating outwards. It's going to be from when the first iteration hits, it's going to be on a 1. Okay, cool. So now that we have all of this, the next goal is to do the next step in the iteration. Which means I copy all of these. I will then paste the formatting, only the formatting here I'm just going to do. And now you can clearly see that there's a bit of a difference because of this, but I am going to do this. It's a slightly more defined. Just slightly more defined, because that might be relevant. Who knows? Right border. Okay. So you can see it a little bit better. What I'm going to do now is I'm going to look at the relevant cells once again. And now this cell is going to say, first of all, equals if, since it's now 216 away, but in the same exact position, it's row, same thing, column minus 216. If that is equal to a hash, then we have slightly different rules. Where our rule is, yeah, because you see that's the exact same as our top left corner here. So if this value equals, actually in this case it equals 2 or 3, so I'm going to do it slightly differently. If the absolute value of that minus 2.5 equals 0.5. That's just me testing if it's a 2 or a 3, because if you subtract 2.5 off 2 and 3, 2.5 gives you a negative half, 3 gives you a positive half. Check absolute value, it gives you a half both times. No other values will give you that. Check if it's a half, then you're good. If that's the case, then keep it alive, otherwise keep it dead. I am going to use dots to show us how it's expanding. Actually, no, it's not even going to be how it's expanding. It's just going to be using dots to show negative. So from now on, all the other ones are going to be dots instead of blanks. And then other than that, if that's not the case, if this equals 3, then life. Whoops. Yeah, I know. Otherwise. So where was that? That was over on the right here. So now, that should be a dot. Is that a dot? It looks like a dot. And now, bam, that's second iteration. That's the that's that iteration. So I'm now going to do a copy of that. I'm now going to paste the formulas. It's going to take a second to think. It's slightly different because it doesn't include its own cells. Now formulas, again, they should have absolutely nothing within. Paste formulas again. I'm going to take these, bam to bam, copy, paste formulas, and now I'm going to copy all of these, because now they should only go up to the 7, because that's the end. Paste formulas to go view 2, 3, formula down to here just so I can see that it's clean. Whoops. And then we'll just paste formulas. So now we've officially gotten the second iteration up here. This is now the official new second iteration, and it shows in all 4 of our dimensions we care about. So, what's next? Well, actually, we're pretty much done, I think. I think if I didn't fuck this up entirely. Let me just paste that. And it should be our next iteration. Might have to think for a second. Nani? I don't know why that says that, but we're going to paste formulas. We're just going to do this again. We're going to iterate one more time here for a quick second. Paste formulas. Okay, I did that correctly. That looks right to me. Okay, and then we'll once again try this one more time. We will take that, copy. Make sure nothing screwing is going on. Paste should work. No ridiculous values. Looks like it's iterating out one more degree. You see now that we have values pushing in one more dimension here. And now, I think the next step is the funniest one, where I'm going to do the least amount of effort necessary in order to be able to do the rest of this. I will come here and I'm going to hide all of those. I'm going to come here and I'm going to hide all but these. Now, why would I do such a thing? Because now I can just do this, copy, paste. What? Oh, because I gotta... Right, I gotta do the vertical too. Ugh. I'm just gonna do it like this, just because it's slightly more kosher, just to make it look a little bit nicer. Hide. I don't actually need to do it like this, I'm just doing it like this because it looks... It'll make the pasting a lot cleaner. Hide. Okay, so now we've got that range. So that's iteration 1, that's 2. It's not going to do the hide, I guess. That's a pain, but oh well. Now that I've got, that's 2 iterations, I can now do 3, 4. Which, I mean, I don't want to hide all of these. I want to be able to get in between. So that's 1, 2, 3, 4, 5, 6, 7, 9, right there. We'll hide that. We will hide those. So you've got 1 iteration, 2, 3, 4. I could go even further, but I'm not going to because that'll kind of break everything now. Okay, so now that's all pasted. The bottom of the 6th iteration doesn't matter because this is what happens on the 1st, 2nd, 3rd, 4th, 5th. I'm going to come here. I'm going to go about halfway up. Okay, so I'm going to hide that. And now I'm going to unhide the rows. Why would I do such a thing? Excuse me. Oh, those are just double digits. Okay, that's fine. If I did this correctly, then we should be seeing, in this upper row, pretty much everything being filled. Well, not pretty much everything. I guess it's like all of the areas here should have things within them. Yes, and this would have just gotten them now. So, now that we have that, the final step comes, and I say, all the way on the right here, I'm just going to come here. Let's do 1 over here. There we go. Equals countif. Range will be row, column, minus 1. 2. That's just going to be that's all right there. Because that's the lowest that all those count up to. All the way here. All the way to the left. Up there. That should count all of them. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 310. That's not the right answer. That's not the right answer. Okay. Is this not iteration 6, first of all? I think it is iteration 6. Does this include all of the values? It does seem to. I thought that looked good. I don't want to have to do this by paper, by hand, either. But I think that looks right, right? Is that all right? And this is the end of the 6th iteration, right? Because that was what happened after the end of the 1st iteration. 2nd, 3rd, 4th, 5th. This is the end of the 6th. Right? Thought I had it. Fuck. .310 isn't the right answer. Okay. Are values pretty much reaching the edge? No, they aren't. They aren't even coming close. Yeah, looks good. Well, let's check this here then. Make sure that this isn't fucking up somehow. Is that really 11? Well. Oh, wait a second. Okay. This is incorrect because I literally said this is going to be an issue and I just completely forgot to take care of it. Okay, we're going to come back and close these again. Hide. We're going to close the verticals again because, actually no, wait, we counted the cells incorrectly. That's what we did, okay. Okay. How do I know we counted the cells incorrectly? Remember how I said we have to count for double on the opposite side? The top counts double in both ways. We have to make sure that we count those doubles, importantly. Those are relevant. So, how do I do that? What's an easy way of doing that? I mean, there's an obvious way of doing it, right? Because the 1 will count, if you count that, double, it'll count all 4 corners. So maybe the easiest way is just to... Oh, that's going to be ugly, isn't it? Maybe? Maybe not, actually. Maybe this will actually be really pretty. We're going to figure this out. I've got an idea, and I gotta love good ideas. Okay, so, what's my main issue right now? Well, remember how I said before we got to count for double? Well, this right here isn't counting the opposite sides. Oh, this isn't counting the opposite sides as double. So how do we count the opposite sides as double for when we're counting these? Easy. Just make it double. So what I'm going to do now is I'm going to, because all of these have formulas in them for all the other ones, I'm going to change this formula so that this is going to be referencing and just always looking at this. So that this will always see both of those as well, because that's also important. This will equal this. That will equal that. Wait a second, is that right? Oh no, it's relative to the position, isn't it? Because what, like, x minus 1 will be this. But what is that value? Oh, it's a perfect mirror. Yeah, it's a diagonal mirror. I think I'm just going to make... Okay, wait. Okay. Gotta go back in my third-dimensional mind again, because I was correct about how these grow. So, when I look at the minus 1, this is identical to this. But this... Well, no, it's still going to be identical to this. This is going to be identical to this. This will be to that. This will be to that. Because these flip perfectly. Which means this is identical to what? This? Because this is the center. So it all revolves around this. Yeah, it flops along the middle of this area right here, because that's what we just learned as a middle. So, yeah, okay, I can fix this. I can fix this pretty great, actually. I think I can do this fairly easily. Fingers crossed. So, how am I going to fix this super easily? Let God unhide. Okay. That is just correct, I believe. Okay, I think that's also just correct. And then this equals that to there. And that's that reflected. So now, I take this, and I paste the formatting. Oh, well, I mean, it should be this, right? Okay, and one more here. And I don't need to do the bottom row, I don't think at all, because I'm never referencing it, because by the time I reach down here, that's the last segment. So I never need to reach the bottom row. So I can just copy this. And I think that should fix all the issues, because now it'll double count everything the way it's supposed to. And you know how we figure that out that's correct? We just simply take this, hide, and now we get the fun part. What I'm going to do is I'm going to copy them over, copy all those changes over nice and quickly. You might think, how could you possibly do that nice and quickly? No, I should probably do the half these just in case thing. Okay, all the way down to here. Nope, there. Hide. I'm doing this because it makes things easier, slightly easier to copy. So I will come here, and now that all copied, bada. And that should now fix all of that. Bam. Okay. And now we will reopen this again. Whoops. Unhide. And now we're just going to go check that. I think that should still be correct. Oh, no, that value is going to be wrong. I don't even know where to put it. Okay, here. Yeah, where is it referencing? No issue, no issue, no issue, no issue, no issue. And then it cuts off before there. Then it cuts off before there. Doesn't see any of the outer values. Yeah, okay. What is it? 535? Is that the right answer? Not the right answer. Okay. Okay, so why is this wrong? Oh, I'm just fucking stupid. Because that these actually do expand all the way. Okay, yeah, okay, wait. Yeah. Nope, I'm just dumb. I'm counting these wrong now. Now that I fixed that issue, I'm now just counting them wrong. Okay. Because these values are single counted, but all the other ones are double counted. So, columns, 6, 7. I'm just eyeballing these right now. That's 68, okay. 24. Undo that, and we're going to do that. Plus that. Okay. So that's the extra corner we have. We are counting all of the above plus 3 times that, because we have to do all 4 of the corners of dimensions we're working around here. So this takes 1 of each of those. Oh, I should be doubling that except for the middle, right? So I'm doubling to those sides. We should be having those little corners. We have in both the other dimensions, and then we have to remove the middle because we're double counting it. Minus. I mean, we're not actually double counting because there's literally nothing in there. But I'm going to do it just for posterity anyways. And I think that's the correct solution. Because we have... Okay, we have the square. We're counting those guys. Have to be counted... all of those get counted for twice total. Oh, but we're doubling up all of them. So if we're doubling up all of them, I only need to do this twice then. Because... what it is, I took these and I doubled up so I have the opposite corners. Now I need that little bit again, so that's 2. And now that I've done all of that, I've subtracted. Okay, yeah, this is the answer. 1805. Come on. Please. Fuck, what did I do wrong? Okay, there's something I'm doing wrong then. I'm pretty sure that this is the correct way to evaluate this area. I'm like 95% sure. Okay, let's just make sure I am evaluating this correctly before I go back and rethink everything. I have the entire full quadrant with the sides relative to the 0, 0 counted. once, then twice, meaning I'm only missing out on the outer corners. So I can take that little corner and do it twice again. So twice, inner corner, twice, that's fine. Yes, that's fine. And then I count in the middle and subtract those. That looks fine to me as well. Which means there's something about the math I think that I'm doing wrong. I'm an idiot. I'm an idiot. I'm a fucking idiot. Okay, I understand why I did wrong. I just looked at that for a second, paused, and realized, fuck, there it is. Okay, so the problem is that it needs to be transposed. Because this is mirrored. It is strictly mirrored across. Oh, is it? No, it's not mirrored, is it? The XY isn't mirrored. That's just mirrored, right? Yeah, because those are they're stacked vertically, essentially. So those don't need any flipping. Then what's wrong? Yeah, then what's wrong? That's my actual question now I have. What's wrong now? Actually, you know what? You know what I think I can do? I think I have a really good way of troubleshooting this. It's gonna take a couple seconds to... Okay. I'm going to take in the sample input and see what it says. So it's dot hash dot hash 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 hash. Okay, so that's what that says, is just the value. After one cycle, it should look like this. Okay, let's check if my algorithm is doing this correctly. By checking here and seeing if it actually evaluates that correctly, because it now has... That's correct. That's correct. That's correct. Wait. How does it do this? Okay, wait. So this is... Okay. Wait. What? Wait, what? Oh, sorry. This is okay. Yeah. This is my 0, 0. That's my 0, 0. That's correct. Let's say this is my z direction this way. So z minus 1 or plus 1 should be identical. So my z minus 1 and my z1 are both identical. Then my w1 should look like that, yep. And then so should the same, both of them. Yep, okay, so that is correct. This is exactly what it should be evaluating to. Okay. Hide that, and now we're going to do our next iteration, because now they do a second cycle. Oh, wait, what? Okay, that's funny. Yeah, so this is correct. That's z2 minus 2. z1 w2 is blank. z0 w2 should look like this. Whoops. which it does. But why does this look different? This looks different. Why are these different? Why indeed? Yeah, why are those different? There we go. We're tracking down the issues now. Okay. Something is now screwy. I can't tell what. Because this is correct. But this is not. Okay. The fuck? Well, I now know why this is broken. The fuck? Yeah, what the actual fuck was that? Is that in my other solution too? Is that why that's all broken? Yeah, okay, now that's correct. That might actually be what's breaking whatever the fuck is wrong with my... I wanted to look over this footage afterwards and see what the fuck happened. Because that is hysterical, but I don't understand what the fuck happened. Yeah, I'm just doing this because it means that I can check this value at the very, very end very quickly, and I won't have to do very much effort for it. Oh, come on. There we go. So now, I can take this. Bam, bam. Wham, bam, thank you, ma'am. Let it evaluate a bit. Okay. 1476. Let's try that. 1476. Not the right answer. Why, dude? Wait, what? Why did we have... What? 836. Okay, well. Look, what the fuck? Oh, wait, I'm doing the wrong... Okay, I'm in the wrong puzzle. Wait, that's why I'm looking at the sample solution here. But, if this is what's causing the issues... I don't know how the hell that even happens. But it did, apparently. Didn't even happen in any of the other ones. What the heck? It's just that one. Yeah, me putting that into the solver there was just dumb. I should not have put that in the checker. Hide. $2260 is what it's getting right now. I put in 4 incorrect answers, so I actually have to wait, which sucks, dude. So I think now that I've actually troubleshooted out the bug, which I don't know how the hell that got there. But now that's troubleshooted out, I think I should just have the right solution now. 2260 looks right to me. Okay, double checking my I got the full sheet here. Those would be mirrored, those would be mirrored, those would be mirrored. Okay. Because it goes flip, then flip, then flip. So those are correct. Those are referencing correct. Over the middle. So if I have over the value, then that will be right across there. That's there, that's there. Those are fine across. Cool. Cool. Okay. Yeah. This maths out to me so far. So once again, I got 2 times that entire corner. It means I have all of that. So we've got those 2 completely sided, and the corners plus 1. So take that away, put those in. That should be the answer. I think 2260 is the answer. And that is my time, 4:52. But now I've got to wait the 5 minutes because I'm big stupid. 2260. Okay, making sure that I didn't miss anything else here. Let's actually just play through the entire dummy question here. So 112 on state 3. After the full cycle boot, it says 112 according to the sample. Oh, well, maybe I should do this. Looks like there's nothing hiding in here. That's anything fucky. There doesn't seem to be. So now I'm going to check through the 3 cycles. That's 1 cycle, 2 cycle, 3 cycle. So it's after 3 cycles. Let's unhide that. It says it should be -2. Oh, sorry, wait, I did this wrong. Wait, what was the final solution that it gave here? 848 is what it says. Was that what it has here? $836. So I say 836. This makes me feel like I'm miscounting. I'm not evaluating wrong. Okay. Oh my gosh, it says 848 cubes are left in the active state. Why do I have a different number? Why are those so different? Wait, shouldn't those be, like, identical? Wait, no, they shouldn't be identical. Because increase in dimension means that they're going to fuck with each other in the opposite dimension, right? Yeah, because they check each other. But wait. What? Why are they different? Should they be different? Should be symmetrical, right? Because they both start on the same... Three, 4, 1, 2, 3. 2, 2, 3. Yeah, they should be the same. Uh-oh. So this is my true corner, which means these two should be the same. These two are the same. Why do these keep being the same all the way down and then suddenly stop? Those are the same. Those are the same. It's like no values here. What the fuck? Wait, what? Oh, are these just wrong? Jesus Christ, driving me up a fucking pole here. I see what's causing this issue. It's called me being a fucking dunce. If there's desync, it's because there's a fucking error somewhere. So 865 is fine. So 865 is being fixed. Which means if I do this like this, this should ultimately fix that issue. 848. Okay. Actually, now that I've done it like this, I may as well. I may as well just put in the actual input into this now fixed space, which is really funny that now. That's why I had that separately though, because on the off event that I completely dicked everything. And that's why you use test inputs, ladies and gentlemen. It's going to have some impact. Paste values. Give it a couple seconds to evaluate, and then it says 1696. That's what I'm formally going to put in now. Yeah! Suck it! Less than 5 hours. Sub 5 hours. Look at that. Just barely sub 5. Barely sub 5, but it still fucking counts, dude. Oh, that is how you do that in Excel. And you know what? This should not be... Actually, I can just do it like this, can't I? I can move that and it'll change those values so it's correct. That's what I like about Excel too, because this doesn't really work this way in Sheets. Oh. Sub 5. Sub 5 hours.